algae, and finally you can see phenomena such as massive deaths of fish and changes in ecosystems.
Ô nhiễm dẫn tới sự phú dưỡng hóa, có rất nhiều chất dinh dưỡng ra sông hồ, gây ra sự phát triển các loại rau thảo và khiến cho các chết.
More directly, the production, this high agricultural production, brings about release of CO2 and greenhouse gases, and the growth of meat brings about increase in methane production. This is also going on with the price, but let's talk about the meat. And methane is a very, very important greenhouse gas, and it's increasing rapidly.
Sự sản xuất làm tăng lên các khí nhà kính, sự nuôi gia súc cũng được tăng lên cao.
Okay? Now, let's look at your neighbor as an example. If you look at China, there's almost a billion 400 million people in China. When you look at their economy, they used to have, in 2010, per capita, $7,500. Now, well, that's different types of estimation. Now, when you look, it's increasing every year. The economy, like here, is growing very fast. I'm taking China because it's the most populous country in the world, and it has a very fast developing economy. Why am I bringing that up? The question why I'm bringing that up is that Chinese people, like Vietnamese people, like any people, want to have what we call a better life, right? And what is in our thoughts usually a better life? We want to have cars, we want to have more clothing, we want to have all this electronics, and we want to travel, right? And in addition to that, we also want to have better food. So it means that the food that you saw, in Germany and in the US, why should only Americans and Germans have it? Why not Chinese people? Why not Vietnamese people? We all want to have these good things, right? And that's the challenge. How do you bring about increasing production to sustain the needs and the demands of all people without ruining? You already see the consequences are only a small part of the world living like this. Think about everybody living like this. What are the consequences? We have to face that, and we have to find solutions. The solution is not going back to only eating rice. The solution is, of course, to have everybody get more than their basic needs, to have a comfortable life. But we also have to face the price of it and find solutions for it. Okay? Because all what is pollution and stuff that we talk about are unintended consequences. No one wanted pollution out of the pollution. These are things that come up we didn't know, And in order to go ahead with that, people like this woman in the 1960s who already thought about the consequences, but no one listened to her. And when you look at consequences, this is, for instance, a sea in Russia. This is 1977, in 1989, and in 2006, they dried it in order to take the water to grow cotton. This is the Aral Sea. It used to be a very large sea. I think it's in Kazakhstan, right? So these are all these consequences. This is dried up sea. All these consequences are to be faced. The pollution of pesticides, etc. So these are the negative summary of the green revolution: air pollution, soil pollution, water pollution, reduction of biological diversity, constant cultivar needs. Pesticides have to be changed all the time. There's mental health effects and unsustainability. We cannot go on like this.
Gây nên là ô nhiễm không khí, ô nhiễm đất, ô nhiễm nước, giảm cái đa dạng sinh học, và cần phải có một sự kháng thuốc từ sâu và có hại cho sức khỏe và phát triển
there are solutions. And we're all here in order maybe to bring a little bit of ideas that can help. So we need novel thoughts, new approaches, new technologies, biotech, green chemistry, genetic engineering, organic farmer. What about the economy? What about the social order? Everything has to be investigated. And we have to be also, I think, open to the idea that what we're doing today, in order to solve all these problems that we created yesterday, are going to bring about new problems. So there is no magic solution.
Chúng ta có những cái công nghệ mới, cái phương pháp tiếp cận mới và suy nghĩ một cách cởi mở và suy nghĩ rộng ra cái bức tranh toàn thể.
You know, Einstein, I heard the word Einstein a number of times since I've been here. Einstein once said, in order to solve the problem, something like this in a free translation, in order to solve the problems we created yesterday, we have to be much more, today we have to be much more intelligent than yesterday when we created the problems we have to solve.
Einstein có nói là để giải quyết được vấn đề thì chúng ta phải trở nên thông minh hơn là cái chuyện đi qua, chúng ta tạo ra cái vấn đề.
So for instance, all of these things like biofuels, wind farms, photovoltaic, they are all great, but we can talk about it if you want later on. They all bring their own problems as well. So nothing's perfect anyway, okay? So that's maybe what is also at stake with agriculture, this field with a question mark. We're trying a little bit to answer this question, and we try here to do a little, you know, maybe opening in getting there. Okay, let's see. And if you have any questions, comments, I don't know.
Các anh chị có câu hỏi vấn đề
Chị nói rằng gì?
Cái gì mà nếu mà đánh dấu một ký luôn.
Có đánh dấu rồi không? Nhà sao? Mình học ngày nào cuối ngày đó hay là
Em hiểu chị Sơn chương trình luôn. Em có đi về được chị. Cái này là chưa hả?
chị mới sáng gì?
Em á,
Đây thiên nhiên hả?
em ở lại đây luôn mà. Em đi ngoài
Là cái
địch ăn á.
em tưởng không được rồi.
Okay, so, hello everyone, my name is Zohar Pastana and I'm a bioinformatician, and I am going to try and talk to you about several bioinformatic techniques and how they are applied. Okay. No, forget it, it's okay. And I'm going to put a very heavy emphasis on practical work. So I'm going to try to teach you about the concepts and mathematics behind our bioinformatic processes, but more than that, I want to do some hands-on experience with you, and I want you to do it with me. So what I'm going to do is I will have some of these slides. I will talk about them. And as we continue further on with our course, I'm going to rely less on the slides, and we're going to do things ourselves. Hopefully the internet connection here will be fast and good, so everybody with a computer can follow my lead, do what I do here, and I want you to experience it for yourself as much as possible. So whatever I do here, you do it with your own computers. Okay.
Dạ, ngày hôm nay thì thầy cho hai sẽ dạy cho thầy những cái khái niệm cơ bản trong tư sinh học mà thầy đặt nặng cái vấn đề còn hơn là bên cạnh những cái slide thì thầy cung cấp cho mình những cái thông tin về toán học hay là những cái cách ứng dụng của các công cụ trong tư sinh học. Thầy hy vọng là cái ngày hôm nay mình có đủ cái tốc độ để cho mọi người đều có thể thực hành chung với thầy.
Okay. So. This is the book that I have found to be the best for this level of bioinformatics. There are many books about bioinformatics at the introductory level, but most of them are too large, too complex, or have too much mathematics in them. The one that I like the best is called Bioinformatics for Dummies. It's a bad name, but a very good book. It gives just the basics and the hands-on knowledge of what most people want out of bioinformatics. You don't have to go and buy it. It's I'm just showing it for you. So if you want to have more knowledge or read about it in more depth, because we're not going to have a lot of time here, you can just go on and get it.
Dạ, thầy giới thiệu cuốn sách mà thầy rất là tâm đắc là cái cuốn này là nó không có đi sâu vô đơn, mà tức là chỉ cung cấp những cái thông tin cơ bản, những cái thông tin mà người ta cần về tư sinh học thôi.
No, great. Okay. So what I want to do is provide you with a solid introduction. We're not going to be too complicated with our time here. And I'm going to show you how to use several tools to analyze nucleotide and protein sequences and apply them to several questions in basic bioinformatics.
Dạ, ngày hôm nay thầy sẽ cung cấp cho mình những cái khái niệm cơ bản, những cái công cụ cơ bản sử dụng trong tư sinh học. Thầy sẽ không đi sâu vào những cái khái niệm phức tạp, chỉ có những cái cơ bản thôi. Và thầy sẽ hướng dẫn cái cách sử dụng những công cụ này để phân tích trình tự nucleotide và protein và đồng thời để giải quyết những cái vấn đề nghiên cứu.
Okay. What I'm assuming is that we have a PC with Microsoft Windows. We have a good internet connection. We know how to use the internet browsers. And you have some background in molecular biology. But I'm going to do a little bit of a review later. And that you don't want to become a full bioinformatician, but just to know the basics of what you need. Okay. So, does everybody here have a knowledge of basic molecular biology? Right? Okay. So I'm going to do a very, very quick review. It will take about 5 minutes. And I'm going to talk about the most basic things that we want to know in bioinformatics. So this is a cell, an eukaryotic cell. There's a lot of things going on in the cell. There's DNA replication, DNA transcription. So DNA makes more DNA, DNA makes RNA, and there's RNA being translated into protein. But from a bioinformatic point of view, for this course, all we care about are two molecules, DNA and protein, two types of molecules.
Thầy sẽ dành 5 phút để tóm tắt sơ về cái phần sinh học phân tử. Và đây là một cái tế bào nhân dẫn của vi khuẩn nhân dẫn, là trong tế bào thì có những cái quá trình như tự tổng hợp, giải mã, sao mã, giải mã. Nhưng mà ở cái khía cạnh tinh sinh học thì chúng ta chú ý vào cái phần DNA và protein.
Okay. Now, very quickly, what is DNA? DNA is made of 4 types of nucleotides: adenine, cytosine, guanine, and thymine. And these are known by their one-letter codes. Adenine is A, cytosine is C, guanine is G, and thymine is T. Another letter we are going to face a lot is N, which is any nucleotide. So if we don't know if a nucleotide is adenine or guanine or thymine, we just call it N. These nucleotides. Each of them has 2 sides, a 5' side and a 3' side, and they combine. So a 3' side is combined with a 5' side to create long chains of nucleotides. So we can read these chains from the 5' terminus to the 3' terminus, or the other way around. We choose to read them from the 5' terminus because this is the convention, this is how everybody does it, and to avoid confusion. For us, from a bioinformatic point of view, a DNA molecule is eventually a string of letters: A, C, G, and C, and sometimes N. So this is what a DNA looks like to a bioinformatician. Okay?
Thầy sẽ giới thiệu ngắn gọn cái DNA là gì. Ở bên cạnh những cái ký tự thông dụng, những ký hiệu cho các base trong DNA là AGT, thì còn các ký hiệu thường hay sử dụng đó là N, đó là biểu lượng đại diện cho bất kỳ một cái base nào đó, không cần biết nó là AD hay CTG. DNA thì có hai cái size, hai cái vùng 5 phẩy và 3 phẩy. Mình có thể đọc cái DNA từ hướng 5 phẩy tới 3 phẩy, cũng có thể đọc từ 3 phẩy tới 5 phẩy. Nhưng mà thường người ta thường sẽ đọc từ 5 phẩy tới 3 phẩy, cho nên đó là cái gọi là thống nhất, cái cách đọc thống nhất. Cho nên ở trong bioinformatics, trong tinh sinh học, người ta sẽ không ghi cái chiều đó, chỉ thống nhất đó là ghi như vậy, có thống nhất là từ 5 phẩy tới 3 phẩy. Trong tinh sinh học thì chủ DNA nó chỉ là những cái ký tự AG, GC, hoặc thỉnh thoảng nó có thêm cái từ N hay là bay bất kỳ.
The other type of molecule that we are going to discuss in this course is the protein. Again, proteins are made of individual building blocks called amino acids. Each amino acid is represented by a 1-letter code. So alanine is A, arginine is R, etc. Again, these amino acids each have 2 sides. The carbon side and the nitrogen side, and these again combine to each other to form long chains or short chains. So amino acids combine with each other to form long chains. Again, we can start reading this as MAVLD if we started from the N terminus, or DLVAN if we started from the C terminus. Biologically, it doesn't make any difference, but again we want to be coherent, and we want to create a united system of reading and writing these chains. So we start always from the N-terminus, the nitrogen side, and to us, from a bioinformatic point of view, a protein is a sequence of letters like that. So an insulin protein, it's a lot of things, it does many things, but to the computer, it's A, L, W, M, R, L, and so on. And this is the insulin protein, and this is how we're going to treat it, this is how we're going to analyze it and show it.
Tiếp theo thì chúng ta là trình tự protein. Protein có những cái đơn vị cơ bản của nó là gọi là amino acid. Thì ở bên bảng này là cái ký hiệu của amino acid. Mấy cái amino acid kết hợp với nhau tạo thành một chuỗi dài tổng hợp thành protein. Mình có thể đọc nó từ cái chiều từ cái vùng nitơ và carbon, hoặc có thể đọc ngược lại. Nhưng mà để thiết lập một cái hệ thống chung cho cả thế giới thì người ta sẽ đọc từ N tới C. Cho nên trong sinh học tinh sinh học thì cái trình tự protein sẽ không có ghi thêm cái NC hay gì đó, người ta chỉ ghi những cái trình tự amino acid thôi, rồi mình sẽ tự hiểu nó là đọc từ N tới C.
Okay. As you can see, Edward is talking about very big, important concepts, and I go right into the basic stuff. So, how do we combine DNA proteins? How do we go from DNA to proteins? We do this by the table of the genetic code. In my opinion, one of the greatest scientific achievements of the last 50 years. And this table shows us how the genetic blueprint, how the plan of the DNA is translated into the proteins. So, what happens is that we start with the DNA sequence, which is the blueprint, the plan. Then DNA is decomposed into triplets of nucleotides, and each triplet is translated, according to the table, into a specific amino acid in the cell.
Thầy giới thiệu cái quá trình từ cái cách đọc từ DNA qua protein. Thì ở bên đây là cái bảng về cái mã di truyền. Theo quan điểm của thầy thì đây là thành tựu lớn nhất của di truyền học. Từ cái chuỗi trình tự DNA ban đầu thì phân tách thành những bộ ba của nucleotide. Sau đó thì dựa vào cái bảng mã hóa bên đây chuyển nó thành chuỗi amino acid.
Okay. Now it's important to remember that each DNA strand, DNA is a double helix. So each DNA molecule has two strands, and each strand has three potential different reading frames. So each DNA molecule, each piece of DNA, has a potential to generate, to be translated into 6 different proteins. And usually this doesn't happen. We only get one specific translation, one specific protein from each part of the DNA. The cells have various mechanisms to make sure that we each time get the same protein from the same DNA.
Thì mọi cái đi có DNA đó là cấu trúc đôi, là có nghĩa có 2 chuỗi mà mỗi chuỗi mình có 3 cách đọc, cho nên là 2 chuỗi mình sẽ có 6 cách đọc protein. Mà thường cái điều này nó không có xảy ra là những cái tế bào nó có cơ chế để nhận diện riêng, là mỗi lần nó sẽ tổng hợp một loại protein giống nhau.
Okay, now I'm sure all of you have, all of you know this much better than myself, but just a very quick film just to remind us all of how this thing works. So let's give it a try. So what we see here, everybody see this? So we have a cell, in this case an eukaryotic cell. So we enter the nucleus. Inside we see the DNA double helix, and the process is that the DNA double helix is the blueprint, and there are cell machineries which unwind it, a certain part of it, not all of it. So the DNA is unwound, and then it is transcribed into messenger RNA. So we are creating an RNA molecule, a short RNA molecule. Then RNA detaches from the DNA and the double helix winds again. The RNA, the short molecule, then leaves the DNA, in this case through a nucleus pore, and then it will go out into the cytoplasm or the cytosol, into a specialized organelle called ribosome. And it sits on the ribosome, and in the ribosome it is translated into protein in the way that we just discussed. So this is the triplet: 1 nucleotide, 2 nucleotides, 3 nucleotides. This is a triplet, and each triplet corresponds to a specific amino acid. So you put the triplet here, and the amino acids combine here to make a protein. So the RNA leaves to be degraded, and the protein then leaves the ribosome into other specific areas or specific organelles, in this case, to get the next phase of creating the protein, which is the folding. So protein, it's important not only what is the sequence of the amino acids, but also how it is folded. So each protein needs to be folded in a very specific way, and then once it is folded, it is taken up by other cell machineries, and it is transported into the place inside the cell or outside the cell where it does its work. Okay. Okay. Rewind. Okay. So we start with the DNA double helix.
Đây là cái tế bào nhân chủng. Đầu tiên mình đi vào cái hạt nhân để xem DNA.
The DNA is unwound.
DNA sẽ tháo sáng để bắt đầu quá trình.
Sao chứ?
Đây là DNA tháo sáng để bắt đầu quá trình tiếp theo.
Now, a part of the DNA will be transcribed, will undergo transcription into messenger RNA.